Okay, for this video I'm just going to go over the basics of the web crawler project, which is our second project. I talked about this in class, so this is just a recap of things that I've already said. And so right now I have on the screen the actual project assignment, the PDF, and eventually we'll switch that to the pseudocode for the web crawler. But the basic idea for this project is that we're going to be writing a web crawler in Python and then saving it in the database. And we've gone over all of these things, so basically I'm just going to try to give a big picture overview and tie a couple things together for you. So the first thing with the project that it gives us up here is that we have a database schema that we're going to use. And so that's something that we want to be aware of. And the first thing I'll talk about is what that schema is. And it's a little bit further down. The requirement is right here, but at the end of the project is where we actually have this schema. So if I scroll down to that part, so at the bottom of the screen we get a description of our schema right here, and so this is what we're going to talk about. So basically we're putting the network structure of the World Wide Web into a relational database, and a network has nodes and edges, and so basically we're going to have a table for each one of those things. So we've already done homework 6, which is for a graph abstract data type, and in there we just had nodes and we had edges, and any kind of label was enough to define the nodes, and the edges then was a relationship between two nodes. So now that we have the World Wide Web, then what we have is a node is going to be identified by a URL, and we've talked a lot about how we need to normalize URLs and things like that. And so then an edge is going to be a link from one URL to another. So a normalized URL is going to be unique, but because we want to have auto-generated integer keys, we don't want long keys that are strings, we just want nice simple numbers. Then we have URLs in our table, but they're not going to be the primary key. So what we have is a table of web pages, and then we have a table of links. And so this is going to be the nodes, our pages table. And then the other table, the links table, is going to be the edges. Each one has an integer primary key that's auto-generated. And so the way we get that in MySQL is in the create table statement. If we're going to make a table called pages, then when we define an integer that's going to be a primary key, so I don't want to write out primary key, that takes too long. The key idea is on that same line before we do the comma, then we can tell MySQL that it's going to auto increment. And so what that means is every time we insert a row, we don't have to specify a value for the primary key, but instead it will start at a given value, and we have control over that, but if we don't specify it, it defaults to 1, I think, and it will update every new row it puts in. It will add 1 to the previous value, so it manages all of that for us. So that's all we have to do to define that column. So the URL is unique. It's a normalized URL, but we're not going to use it as a primary key, but we still need to store it. And then also we need to store the text content or the HTML of the page, whichever we want to call it. So the HTML content is a column, and the column names aren't too big a deal for this. They're not specified. Basically, if you get it working, that's good enough, and then you can use it in Project 3 because you'll know the column names, or you can use the database I give you in Project 3. And then we also need to know the time that we accessed it, so the time that we visited the page. So that's it for the pages table. The links table, an auto increment primary key, just so we know the ID of each link, and then we have a link is from one web page, and then it's going to be to another. And so we end up with a structure like this: 2 foreign keys in the links table. So this is it for our database. And so the first thing we want to do for this project is from our Python interface to MySQL or directly in MySQL, we want to set up the schema. And so we want to have both create table statements. We make the pages table first, and then we make links. The links table has foreign key references to the pages table, so we have to do that this way. So what we have now is, if we've done this, we'll have a database, and now we need to get a web crawler working, and that's what the rest of the project is about. If I scroll up a little bit to look at the Python code here, the sample code for my working version of the project, then the way it's going to work is we're going to have a module called crawlir, and so we're going to use it by import. So you'll debug this in IPython and then download it as a Python file. It has a class inside it called crawler, and so what that takes is a list of domains, a list of URLs. And so these are the starting points for the web crawl, and these also define the domains that we stay inside. So we don't want to go to external pages that are only inside these. So it takes a list. When you're testing, then what you'll want to do is just give it a list of a single item. So for testing, you would want to give it a nice simple domain, just one thing, and a small one, so something like the ada.ius.edu server that we use a lot. And then eventually, when you're sure that works, you can add a second one to it. You can add www.ius.edu, and then after that, if you're feeling brave, you can also crawl iu.edu in Bloomington. So with the crawler, we tell how many web pages we want to crawl, and this is a useful feature for two reasons. One is that it lets us stop the crawl and resume it, so if we have time constraints, but also it lets us test with a small value at first, so we can tell it just to crawl 5 pages, and then we can look in the database, make sure that worked, and so we don't get into situations where we unleash something that is going to loop and loop forever that we don't quite have control over. So this is why these requirements are like that. After we've crawled, we can save our crawler as a pickle file, and then what the second example shows is if we've done that, we can load that pickle file and resume the crawl. So when we pickle a class, or more precisely when we pickle an object of that class, we're saving everything inside it. So this thing saves to the database, but it also has some things internally. Okay, so I had to pause for a second and I lost my train of thought a little bit. What we're talking about is pickling the crawler. So when we're doing something like that, the reason we're doing it is so we can resume the crawl. And so we don't do anything special about the database. As we crawl, we're saving web pages in the database. What we have to worry about when we're pickling are the things that the object manages. So what we want to pickle is the object that's of the crawler class. And so in my example, that's the thing right here that's I made by C is equal to crawlir.crawler. So that's the thing I just called C. And so that's what I send to pickle.dump. And so what it needs to save is all of its internal data. So we need to pickle the things that it's keeping track of. Because it's doing a breadth first search, one of those things then that we need to pickle is the queue that it maintains. That's kind of the key thing. If we pickle that, so when we dump the pickle, we save it, and then when we load the pickle, we get the queue back. And so when we resume with the crawl function, it has the queue and it's able to pop from the front of it, so it knows where to start again. We also need to pickle any data that's inside our object, and we get that for free. And so any data structures that we're using, so data or data structures. So that means any dictionaries that we're keeping track of things with. And so that would be like our visited dictionary that we're marking nodes with. If we're also keeping track of a dictionary for all the servers or domains that we visit, and that would include that dictionary. And then finally, anything else like a counter if we're keeping track of how many pages we visited, for instance. So basically all those self-dot things are what we get when we pickle. But what we don't have to worry about is the database. It takes care of itself. As long as our crawl method is saving to the database, when it picks up, it'll start saving to the database again. So that's what we need to deal with. There are a lot of project requirements. Now I'll scroll back up and look at the requirements. Like I mentioned earlier, I talked about these in class already. I'm not going to go by them one by one because everyone can read. Remember, when I grade this, I go by the requirements, so use these for a checklist. There's no excuse for not meeting each and every one of them. So the ones we need to deal with, our crawler is going to have to use a queue, and so you can worry about writing that. You've had some practice with that from the homework. Now that I can make homework solutions available, I have a little bit more to say about the queues, and so I can put those things online as well. So it's going to have to use a queue. We need to be aware of robots.txt, and we need to use them. And so what we need to do for that is we need to keep track of a list of domains that we've visited. And so that's why what I had wrote on the screen previously, while we may want a dictionary that lets us keep track of servers. And so we know if we visited a server, we can check and see whether or not it has a robots.txt. So the key would be a domain name or the name of a server, and I'm using them interchangeably. Technically they're different, but for our purposes we treat them the same. So for example, something like www.ius.edu or ada.ius.edu, the value could be whether or not it has a robots.txt. So what that would be then is a robot parser object for the server. And so then every time we have a web page on that server, we can look it up in the dictionary. The value we get back would be the robot parser object for that server, and then we could access its can fetch method. So that's what I recommend for dealing with the robots.txt. Everything else is something we'll deal with the pseudocode. So as far as what else you need to worry about, I'm only going to mention this one here about filtering. So when we visit a web page, we read in all its HTML. We use the Beautiful Soup Python module to extract all the links from its anchor tags. So those are all the A tags that have an href attribute. And then the value of that is what we care about. These are potential URLs. We filter them. So one thing, if they're not HTML, if they don't end in .html or HTM, we don't want to use them. So we only want HTML URLs. So we only want ones ending in those two extensions. So how would we do that? Well, we have a string, and the extension's everything after the dot, so we have a way to split the string on a dot, and so then we can see what's after the dot. That's something that I won't show you sample code for. It's a 400 level programming class. You need to be able to work that out. So we only want to visit certain of those, and then moreover, if we know that it's the right kind of file, HTML or HTM, then we also only want to visit ones from our target domains. Well, so what are the target domains? It's the ones that we specified when we made the crawler. So if we get a link, even if it's HTML, if it goes to an outside domain, one that's not in our list here, then we don't visit it. So you had another pause, you had another interruption, you had another loss of train of thought. So basically that's how we decide if we're going to visit a link or not. So that's something we have to deal with in our crawler. So that's a high-level view of the project, kind of focusing on the important details of the database, the robots.txt, and how we can use a dictionary to deal with all the robot parser objects, and then a little bit about filtering. As far as what we want to do to actually implement the crawl method, that's something that we need to take a look now at some Python code for. So the file I'm going to look at, it's from our favorite page here where all the IPython notebooks get published. It's this one right here, I427 crawling summary.html. And so that's the one I'm going to open up, and towards the end of that we have the pseudocode that we need. So way down here at the bottom, this web page, I've talked about it in another video, but what it covers is some details about how we don't want to repeatedly load pages, but we want to take a little break with the time.sleep method and things like that. So what we end up with is the pseudocode that we have right here. And the last line here, hopefully this is the final version, but there's actually a couple of details that it leaves out that you have to worry about. We talked about those in class. But one of those details, to recap that, if we look at the while loop, the only condition for this thing is while there's still items in the queue, we want to keep on crawling. But that's not quite the case, because in the project we also have a counter. And so what we have to do is, while the queue is not empty, or we're under our maximum page limit. And let's think about that, because I'm improvising here. So while the queue is not empty, and actually we want them both to be true, so I was right the first time. That's what I get for thinking on the job. So we want both of these things to be true. We need pages to visit in our queue, and we need to know that we're under our max page limit. So in other words, we have some kind of counter. We started at 0. We know that we're crawling for 1,000 pages or 10 pages, and so we increment it every time we visit a new page. Once we hit the limit, then we stop the crawl. When we resume the crawl, we do it over again. We set the counter back to 0. We pickled the queue, or we still have the queue as part of our class, and so it's going to have all the pages in it. So when we get a URL from the queue, then what we need to do is we need to scrape that. So we need to get its HTML contents. We need to harvest that HTML for all the anchor tags with href attributes. And then we need to save the HTML in the database. We need to know the time that we visited it. So at this point, this is when we can do all that stuff. As we have a page, though, it's not quite good enough to always read HTML. So remember, we deal with robots.txt for it. So that gets back to that server dictionary. So we deal with the canFetch method of our robot parser object, depending on the domain we're on. So then we need to get the timestamp. We can get the HTML contents. At that point, we can save the page in the database. So this is something we talked about in class. As far as saving in the database, we need to be a little bit careful about that. And that's the other big thing that doesn't show up in now with the large eraser. I have unlimited power. So that's the thing that doesn't show up in the pseudocode here, are some of the technicalities about saving in the database. So the way we want to think about the database is we save a page kind of in 2 phases. So the first time we find a page, the first time we know about a particular URL, so the first time we learn about a URL, we save it in the pages table. The only thing is, sometimes we learn about a URL for the first time when we're reading the HTML contents. Sometimes we learn about the URL because it's a link from another page. So we have to be a little bit careful about how we do that. In terms of telling you what I did, I save every page the same. The first thing I save is the URL. And so by save, I mean add that URL to the pages table. When I do that, that also does the auto increment part. So what I have in the pages table then when I do that is I have a PID value and I have a URL value. And so I do that the first time I find a page. The other 2 things I have to worry about, the other 2 columns, the HTML and then the time visited, I save those right here when I read the HTML contents of the URL. So this is when I do that part. So I update pages in 2 separate steps. The other table in the database, I have to update the links table. I have a link ID. I have from and to. So the thing about that is the from values and the to values are foreign keys to PID. And so what I have to do is I have to know, okay, I have this URL. What's its PID in the pages table? So that means there's a lot of lookups in the pages table. But to save the link in the database, I need both of those. So I have two different URLs. I've already seen them once, even though if I don't know the HTML, they're in the pages table. So I can do a select from where to get the PID associated with the URL. And then when I do that, I can update the links table. So as far as the database, there's kind of three different things that I do with the database. And this is getting a little messy, so let me adopt a different strategy with this. So three things I do with the database. First thing I do is I can save the URL, which automatically also gives me a primary key, which I'm calling the PID, the page ID. And so I do that when I first learn about a page. By learn about a page, I mean when I add it to the queue. And so that means I discover it from another page as a link, or I know about it as the starting point in our breadth first search. Either one of those are the same. So save the URL in the pages table when I first encounter that page. The other thing I do is I save the HTML content and timestamp. So that's when I visit a page. The third thing I do is I save the link information. So that's updating the links table. To do that, I need to know both PIDs. The from and the to. So saving the link information, I want to think about this, thinking back to I308 or I111, it's an insert into query. But to get both PIDs, I need to do two select from where queries. And if you think about this, you can be a little clever, because the from page is going to be the same. If we're reading a web page and we get 50 different links that we're going to add to the links table, all 50 of those are going to have the same from page, and they point to 50 different pages in the to column. So we need to do a select from where to get from. We need to do a select from where to get all the different tos. Once I know both of those IDs, then I can do an insert into for the links table. And so that's the way I can think about the database in here. I'll leave this up on the screen a second, and then I can switch back to what we had before. But that's basically the subtle things you're going to have to deal with. So for the project, you have to turn the pseudocode into Python and then also deal with the database. If you have problems with it, then you can think about them as two separate parts. Get the web crawler working where it reads in all the HTML, and then add in the database part. You can get a lot of partial credit if you do that. Of course, to get full credit, you have to have everything working, but deal with it in two phases. For the project, we already know breadth first search. That's something we're considering essentially elementary. That was a homework assignment. So now you're adding in the complications of dealing with the web, normalizing URLs, and then also saving it in the database. Those are the two things you have to add for the project. You can treat them as two separate parts. Get one working, and that would be the dealing with the web, normalizing URLs, and then save the database for last. Once you know that you have a working crawler, and the way you know is you can use print statements to actually print out things like HTML or print out links or to print out all the pages that you're visiting, and then finally add in the database stuff. And then you know the database is working when you actually see the stuff appearing in the database, and you can check it. So that's my advice. I'll switch back to the original screen, but once again, this is the pseudocode that we want to use for our project, and I'll emphasize that with violet green because that's not a color I've used yet. Okay, so there we go. That's that.